the World Computer Congress opens in China, we explore what obstacles do computer scientists now face. Welcome to The Point, an opinion show coming to you live from Beijing. I'm Jonathan Betts, sitting in for Liu Shin. Building on the theories of Alan Turing, the father of computer science and many others, much of humanity now enjoys the benefits of computerization, like surfing online, cashless payments, artificial intelligence, and so on. But where will it go from here? As the 2019 World Computer Congress kicks off in Changsha, China, experts will discuss such issues as should the existing theories be updated to advance the next wave of technological innovation, and what challenges must the computer science sector overcome? Joining me for this discussion is Professor Liu Leibo from the Institute of Microelectronics at Tsinghua University, Andy Mock, a senior research fellow at the Center for China and Globalization, and Einar Tangen, a current affairs commentator. Great to have you all of you with us here today. So the World Computer Congress kicking off in China. Einar, let me start with you. What is the significance of this, and what are you going to be looking for?
Well, this is the first of its kind, and it was okayed by the State Council. And it seems that this is a reaction to, this kind of decoupling that's happening between China and the U.S. In essence, China is coming up with its own Computer World Congresses and other meetings where they can foster innovation. They can talk about what they've done in the hardware, the software, and what the next ideas are going to be.
And what do you think the next ideas are going to be?
Well, I mean, 3D printing, obviously, is a big part of it. How you do the hardware, how you do the software, and the whole development process is changing. Today, it's less about the individual, more about the process itself. For instance, if you're writing a program now, it'll have millions of lines of code, and it'll be done by a team, not by an individual. If you go back 20 years ago, it was all done by one guy, or one guy and his friend.
And so, Andy, when you look at all the innovation that we're seeing, especially in China when it comes to artificial intelligence, robotics, self-driving cars, what most excites you and what do you think shows the most potential?
Well, I'm very optimistic about the outlook for technology in China and as a result if China does well globally. So you mentioned artificial intelligence. So as Einar mentioned, we think about this as almost like a manufacturing process, right? How do we end up with cutting-edge technology products that improve the lives of individuals, companies, and countries? You first have to start with research. You have to commercialize that research. You have to turn it into viable products in the marketplace. So when we look at artificial intelligence, China is leading in terms of not only the volume of published papers, but top papers as well. So for a number of years, people could see the volume of research output in artificial intelligence and other areas of computer science. China led the way in volume, but there was always a question around quality. We look at the last couple of years. In terms of the top cited research in artificial intelligence, China also is a leader. So I look at this as a leading indicator, meaning that we're going to see even more exciting and better things come out of the Chinese AI ecosystem.
But when you say China is a leader in artificial intelligence, what does that mean, and what is that going to mean for regular people out there?
Well, I think it means a lot of different things, Jonathan. So one is that, again, if we think about it from just a pure research, so academic research leads to developments in the laboratory. Developments in the laboratory, if properly commercialized, lead to products that could be the next Tencent, Alibaba, etc. So we see that clearly happening. But now let's look at it then from the consumer perspective. So China is not only a large market, it's a dense market. So what that means is it's creating a lot of data and a lot of different kinds of data. So we can call this heterogeneous data sets, meaning there's video, there's transaction data from online, from e-commerce, there's text messages, and all of these put together help strengthen this feedback loop that allows the cycle to, the machine to run much faster, if you want to use machine as an analogy. So I think it's very positive.
Is it really faster or better? I mean, the whole point about this is you have to commercialize it. There has to be a money stream at the end of it.
Absolutely.
We've talked about this many times.
Yeah, and I think it's both.
Yeah.
And I think it's both faster and better. And cheaper as well.
I mean, so Professor, help me understand this here, especially on the artificial intelligence question here. just how radically is this technology changing, and how much is it going to change people's lives? I mean, what is going to be the difference to people all over the world if this really does take off like we think it will?
Okay, so I have a very famous tweet saying that, so in your cell phone right now you have has more power, computing power than the NASA in 1969. You know, in 1969, NASA launched a man to the moon, but right now we launched a Angry Bird into pigs. You know, so nobody can imagine that we have that requirements. So the computing power of the cell phone is even better, stronger than that in NASA in 1969. So that changed our life a lot. So at that time, nobody can imagine that. So right now, you can see that no matter the artificial intelligence and self-driving, you can see that. So, for example, self-driving. So if you drive the car, you have the information, the road situation, and all of condition of the car. Transfer that one to the computer, which is far away from you, which is about maybe 1,000, 2,000 kilometers from you. And that computer make decision how to drive the car. So that also integrated with the artificial intelligence technologies. So nobody can imagine that change our life a lot.
So let's talk about the self-driving cars, because that's an example I hear a lot.
Yeah.
I also hear mixed stories about it, about how successful it is, how much progress is being made. I mean, when do you think we're going to see cars driving themselves on roads?
Yeah, right now this is you know, one of our objective, but so far, you know, we should see that this is ADAS, this is the automatic driving with assisted system, assist us to drive the car. So far we cannot realize the real automatic driving, but we are toward that way. You know, with the stronger of the chips, stronger of the software. So I don't think this is a dream.
Don't think it's a dream, that it will be a reality.
Yeah, but if there is going to be a place where they're going to have an autonomous city, for instance, it'll probably be in China, because China has the controls. They can create a city. You know, they have many new cities they're making each year, and they can simply just say, look, this city will be an autonomous driving city. But you know, the add-on repercussions, when you talk about efficiency and how all the convergence comes together, it's not just the brain in the cloud that's operating your car. What it is, it's connected to sensors, GPS, sensors in the pavements, to traffic lights, CCTV. They're helping to make very good decisions about what comes next, especially as you're driving. It increases reaction times. But think about how efficient that will be. You know, most of a car today, so much of the equipment that goes into it, the structural and things like this, is all about safety. But if you start taking those things out, think about street lights, how much energy we put into street lights. What do you need street lights for when you don't have a driver that is depending on the visual side of things? Safety equipment will change. The inside of the car will change. It'll be much more about the occupants and how they feel. Perhaps it'll be a sharing economy. There are a lot of questions. But I would add one thing. Despite the fact that, you know, the way we live has changed, but every solution just brings about a new set of issues, of problems. And this is one of the things that, you know, we always have to anticipate. We always think we get to a certain point, everything's great, we stop. No.
Right.
The road continues, and we simply have to set up the next line of equation.
So, Andy, what do you think are the potential risks going forward here?
Sure. Well, you know, I look at this from a slightly different perspective. I'm maybe a little bit more optimistic than Professor Liu is about when we will have completely autonomous vehicles. And I think, of course, there are still some technology issues that need to be resolved, safety, you know, being one of the primary concerns. But actually, this is also as much a political public policy issue. And I'll give you an example. So the technology is advancing very rapidly, and both the US and China are furiously working to create this future autonomous vehicle world. But we look at a company like Ford Motor Company in the United States. So they're rolling out autonomous vehicles that are hybrid engines, meaning that they're internal combustion and electric. And why is that? It's because they have no idea when the infrastructure will be in place for cars to be charged in the United States. Now, this has important repercussions because internal combustion engines are not only more costly, they have more parts, so they more easily break down, they're more expensive to maintain. Now look at the case of China. So China, we look at the governance system from top to bottom. It's integrated and coordinated. So the national level, the provincial level, the municipal level, even the district or neighborhood level is all one line. So what that means is that when the government makes a decision...
It doesn't always work that way.
Of course.
That was my
That's
question.
the theory.
Right,
Because,
yes.
Andy, some argue that is not the best scenario to, spur innovation.
Yes, and that's actually, a very profound question. And I would say, and Einar may push back on this as representing the American view, but I think this is something the U.S. talks a lot about, this myth that you need to have freedom, a certain kind of freedom, to really innovate. And I think, but if we look closely at what drives American innovation, actually, a lot of it was either borrowed or liberated. So we look at back in the 1800s. So a lot of the technology then was actually stolen from the UK. Post-World War II, a lot of the most important technology that is the foundation of American technological superiority today came from the Germans. And the Nazis certainly were not running a democratic open system.
Yeah. No,
So,
I would agree with you. I can see this point. Every new civilization is built on the bones of the ones that preceded it, and you can
but that's
go
not the
further.
point, though,
It's
Einar.
Greece and
The
Rome.
point is that can you have technological innovation in what maybe some Westerners would call an authoritarian system, but not liberal democracy a la the U.S.?
I think that's a conversation that's incorrect. I mean, China, anybody who comes to China will tell you it's a lot more capitalistic than the U.S. is. So from that point of view, you have people who are really striving. I mean, you look at the numbers. Over 90% of new jobs are being created by small and medium-sized enterprises. This is where innovation is, and this is why the Chinese government has put such an emphasis on this area. Your take on this, Professor?
Yeah, so we think we tried a lot. So, we're from university, right? Mm-hmm. So we had tried a lot of our efforts to how to deal with the topmost research topics. So currently, you can find out we, when I was the undergrad student in Tsinghua University, which is 20 years ago, we can find the big gap between China and the U.S. At that time, and we cannot publish the top conferences papers and journal papers. But currently, you can see that. So no matter in the computer area, artificial intelligence, self-driving and chip design things, the EDA tools, and we can publish a lot of top conferences. That's our contributions of the research for that one. So this is I think very important for the innovations.
And I would offer two examples that some of the most important innovations globally actually were not bottom-up. They were top-down. So look at the internet in the United States. That actually came out of a project sponsored by DARPA, so the Defense Advanced Research Projects Agency. So you can't get more big government than the Department of Defense. So it was their funding and their support that allowed the internet.
It's an ecosystem. It comes from all sorts of different places. But the other part of the point is that you can't always predict where it is going to come, the next breakthrough. Let's continue this conversation. We've got to take a break here, and we're going to talk about how to solve some of these challenges and what the potential is for greater international cooperation after this very short break. Well, welcome back to The Point. We have an interesting conversation underway. Andy, I want to turn back to you because we were talking about talent and innovation, where the next big idea is going to come from. And when you look at the Chinese system and its way of developing talent, tell us how that works and how that compares to the U.S. system.
Well, I think the next technological breakthrough requires two things. It requires money and it requires brains. So clearly we can see China is an increasingly wealthy society. So when we look at government allocation support of R&D, corporate R&D, venture capital investing, even bootstrapping grassroots innovation, the financial resources are there. Now, if we look at brain power, I think as Professor Liu was saying, so first of all, we're 40 years into economic reform and opening. There are world-class scientists in China that have not only been trained in China, but also studied abroad, either masters, PhDs, postdocs, worked as corporate scientists. So I think the brains are there as well. So now the next question is, how well is this managed? And I think then to Einar's point, on paper, of course, the Chinese system makes a lot of sense. But of course, like any system, especially any large system, there are inefficiencies, there's always room for improvement. So one of the things I'm particularly excited by from the research side is how the Chinese system also harnesses market forces. And you probably know better than I would, Professor Liu, But you know, one of the interesting features of the Chinese system is that if a academic researcher publishes, say, in a top paper like Science or Nature, they can get a very, very substantial cash bonus. And that harnesses economic forces as well as, I think, just the pure desire to push the technological envelope.
I'm not as certain that that is the way, and perhaps you can weigh in, but I really think that it's the promise of being able to take your innovation to the next level. I mean, so much money has been made in the whole area of taking ideas and putting them into products and services, and that has been the real bellwether. I think if you had a choice between 10,000 kwai for publishing a paper, or maybe a couple of $100 million for taking the fruits of that paper and putting it into production, either as a service or a good.
Professor?
But so actually, I have some maybe a different point. So even though I think the brain is very important, right? So say that money is important, brain important, but so what does the brain focus? For example, if we focus on technology, then currently the technology, from my point of view, almost reaches its upper limit, because of the information theory invented about 60 years ago, 70 years ago. So technology almost reaches its upper limit. So actually, the brain should focus more on the fundamental scientific theory, and the principle of the theory. That's very important.
What do you mean by that?
For example, you just mentioned the Turing, right? Turing machine, and in the telecommunication, the Shannon law, shadow theory, right? And also von Neumann architecture, the computer architecture, and the principle of semiconductor. So that's a fundamental thing. So which were invented about 60 years ago, 70 years ago. After that, technology will take the advantage of those theories and get benefit from that one. So currently we think the advancement of technology actually slowed down. So this is a time for us we are waiting for the breakthrough of the new theory, a new information theory. That's the key point.
So
I would disagree with that.
Yeah.
Quite frankly, we have quantum entanglement. And this is a very weird thing. You can literally take a photon, split it in two. Anything you do to one photon will happen to the other, no matter how far apart they are. China is about to put a satellite involving this quantum communications into orbit. Okay. So these are things where, yes, you start running up against limits, because it's a very eerie thing, because it happens instantaneously, not even at speed of light. It's beyond that, as far as they can see. It's just, you make change here, it goes there. So the possibilities for computing, for communications, security, privacy are amazing. Then let's start looking at 3D printing, new materials. All of this, imagine being able to make things from an atomic level up, so that the material you design is custom made. It doesn't matter if it's an airplane or it's cufflinks or something. It'll have all the characteristics that you want, and it'll be made by a 3D printer. So what happens to the global supply chain? Yes, you need raw materials perhaps, but then we start getting into the environmental aspect. How do we solve this issue of throwing away things that should be recycled because we can use them, because it'll cut down on the basic resources that you need to import. So I think there's whole areas out there where there are tremendous opportunities for technology to be applied to solve human problems.
Yeah, it seems like we are on the dawn of many, many breakthroughs to come, of a new era of innovation. So help me understand this thought that you have, that we are kind of hitting the limits of some of our technological progress.
Yeah, so why we are hitting it from technology point of view, that, for example, the Moore's law, right? The Moore's law says that we can integrate, so the number of transistors integrated onto the same area will double every 1.5 year or 2 years, right? So from about 60 years ago, so the Moore's law works, right? But currently you can see that, so Moore's law is actually, basically is, the law of economics. Because if we scale down the size of transistor, and at the same time we can reduce the cost, then that's fine. However, right now, currently we reach about 7 nanometer or 5 nanometer, and you can find out the cost will increase. Therefore, no strength, no force to drive that one. So Moore's law will go to the end in the near future. So that's up to the limit of the semiconductor principle. At the same time, Van Neumann architecture. So we have 2-core, multi-core, and many-core system, and cache, and a lot of technologies. But we cannot increase the frequency of performance of the processor, and we have a lot of issues could not be solved.
I'd like to maybe add a little bit to what Professor Liu was saying, that why are we hitting these limits? I think one is because if we only have the market focus, what happens is researchers, business people focus on the easy commercialization opportunities. And I think what the Chinese system has also recognized is that to be a great scientific superpower, you can't just be strong at commercialization. There's R&D, so research and development. Within the R, the research side, there's basic research, there's applied research. And I think what China's been historically, in the modern era, very good at is on the applied side, so turning things into products.
Yeah.
Now, the problem is to do things like physics, pure mathematics, there's no money in it, right? So this is why a lot of researchers have avoided that, and this is exactly why I think this idea of giving cash rewards for publications in real kind of science, hardcore R topics is vitally important, and we can see this taking off in China today as well.
Yeah, but
and this will push
Where does it go?
the envelope.
Where does
and
it
I think
go?
we'll address some of the concerns that you mentioned, because I mean, coming from a think tank background, of course, I don't have the expertise to look at it on a very technical level, but to say systemically, what does China need to do to make sure it gets around these barriers or these bottlenecks? And I think one of them is exactly addressing this basic research
But
problem.
you're just talking about timeframe. Quite frankly, all the things you're talking about, study for study's sake, doesn't just lead down a blind alley. These are areas that set up the next technological forefront that you want to develop. So it does always come back to cash. You have to come back to something that has some applicability. You can't just say, isn't this wonderful? There's always something that can do it. Even the things that we've done with the Halogen Collider, the things that we understand about space through the Hubble telescope, things like this. This has real applications within our understanding of basic matter. And from that, we can then extrapolate. So I've never bought this thing that it's two separate things. There's study for the sake of study and study for application.
Yeah, it does seem connected and linked, Andy. So, I mean, how do you respond
I'm not
to
sure I
that?
agree. I mean, because again, if we think about the purpose of scientific research, it's the discovery of knowledge, independent of whether it has any commercial application. Now, of course, a lot of times there is this valuable commercial byproduct that things get turned into products. But I think what happens, again, I mean, to get very idealistic about it, think about art as well. The greatest artists did not create art because they wanted to make a lot of money. They were looking for something deeper. And I think our research as well, scientific research, should not be primarily motivated by economic gain.
Let me introduce you to a lot of starving artists, and I think they'll change your mind.
Well, Professor, I want to talk about the young people of China. I mean, you work at a university. I think you have a lot of insight into this. I saw a study recently saying that a lot of young children, especially I think in the Western United States, they're driven not by the pursuit of science, technology, but by fame. They want to be on YouTube. They want to be singers. They want to be performers. In China, there's this impression that it's different, that a lot of young Chinese people want to be astronauts. They want to be scientists. Do you see that on the level where you are, and what do you think is behind that? Where is this coming from?
In my opinion, I think actually in China a little bit different from the United States. As far as I know, in the United States, the singer, the actor, maybe the football player and baseball player, and the young children want to be that, right? This is so in my opinion, so if they want the reputation, the credit, and maybe the money, that's a good thing. That's a strong motivation. But in China, young people also want that one. But still the engineering and the science are also preferred by the students. For example, I can take Tsinghua University example. So Tsinghua University is now focusing on the technology and the engineering and some science research. It is also very popular by the teenagers. So this is the major difference from that in the U.S. And the other difference is that you can find, China is totally different from the U.S. is that, so every engineer, every scientist, we have to educate ourselves. We are we're China, so we don't have enough engineers from other countries. For example, in U.S., some engineers from China, from India, a lot of countries, right? And they are attracted by the U.S., the living conditions there. But however, China, every scientist, every engineers, researchers should be educated by ourselves. So even
is that
much
an
more important.
asset? I mean, is that necessarily an asset though? Because some would say that the U.S. system, the benefit is it attracts the best from all over the world to come there and study.
Yeah, that's the advantage of the U.S. system, right? But in China, we don't have that. So far, we don't have that advantage. So that's why the education of the science and engineering is even more important.
Yeah, but there's two things I would add. First off, Chinese students, and I hope you'll agree with me, are heavily influenced by their parents, not as much in the United States.
Yeah.
All right. If your parents say, I want you to study hard sciences and STEM courses, you're probably going to do it because you don't have a choice and you feel you don't. In the U.S., parents are very loath to say, you have to do this because the kids will rebel one way or another. The second part is that this idea of this, how you create innovation, bringing in minds, I think is very important, and this kind of cross-culturalization. Everywhere we've seen, it's been exactly the things, those places which have done well. And so the Chinese government is pushing that. They are increasing the number. They're trying to give special status, easy visas, even housing and things like this, cash awards for those leading scientists and talents who are coming into China and helping develop businesses here.
But how competitive do you think China is when you look at other countries around the world, considering just the system in place? The visas and the cash perks are a lot of perks, but is it truly competitive at this point?
Let me jump in on that, because I know that for STEM graduates, science, technology, engineering, and mathematics, China actually produces the largest number globally by far, and it's almost 8 times the number of that of the United States. So I think that shows that I think there is a very broad base of talent that perhaps could be better developed as well, but still I think China has a very powerful advantage here. The second point is that for both the U.S. and China, as big, important countries, these are not mutually exclusive. That countries need scientists and engineers, but they also need people to excel in the cultural aspects, or cultural spheres, whether that's singing, dancing, being a YouTube star. And we see more and more today in China, too, that many kids, because the country has advanced economically to a point, they do have choices.
Without question.
And I think this contributes to a more vibrant society where there are both.
We are going to end it there. A great point to end it on. Thank you all for your time today. Interesting conversation, interesting new future, I think, ahead of us. Thank you all for your time. That's all from this edition of The Point. As always, you can follow us on Facebook, Twitter, using the handle The Point with LX. Download the CGTN app to watch our show on your mobile devices, or go to YouTube and look for CGTN The Point. Thank you so much for watching. You've got The Point.